This video is concerned with the naming of carboxylic acids and their derivatives. We're going to start with the naming of carboxylic acids. Carboxylic acids have this kind of grouping with C double bond O connected to the OH. The name of carboxylic acids always ends in oic acid, and the base chain includes the carbon that's part of the carboxylic acid itself. So this would be 1, 2, 3, 4, 5, 6, 7. So it would be heptanoic acid. We can then add on side chains if we need to. This one has an isopropyl and 2 methyls, so it's 4-isopropyl, 2,3-dimethyl heptanoic acid, using the same rules as we've learned about in the past for positioning and alphabetization. Acid chlorides are actually usually made from carboxylic acids, and they are actually named for the carboxylic acids from which they are made. Just to show you an example, this particular acid, this is a heptanoic acid, can be treated with SOCl2 to produce this particular acid chloride. Now the name of this would be, as I said, heptanoic acid, and the name of the chloride would be heptanoyl chloride. So the ic acid gets replaced with YL chloride, and you can see the same pattern here. The ic acid gets replaced with YL chloride. So that's what I would do when naming an acid chloride. Pretend first of all it's a carboxylic acid, name the carboxylic acid, replace the ic acid with YL chloride. When we're looking at acid anhydrides, we name them based upon, again, the carboxylic acid from which they're made. For example, this particular acid anhydride is made from 2 equivalents of butanoic acid, and it's called butanoic anhydride. We're usually going to be just dealing with the naming of symmetric anhydrides, which are always made from the same carboxylic acid. So you'll notice that we don't need to say that there's 2 of them, because it's always assumed that it's the same carboxylic acid that's used to make both of them, to make both parts of the anhydride. So this would be butanoic acid, and it becomes butanoic anhydride and not dibutanoic anhydride. Here's another example. This one would be made from 2-methyl pentanoic acid, so it becomes 2-methyl pentanoic anhydride. When we're naming esters, again, we name the esters based upon the acid and the alcohol from which they are made. So this specific ester here would be made from heptanoic acid and from ethyl alcohol. The name of the ester is ethyl, which is for the alcohol part, and heptanoate, which is for the acid part. So this is heptanoic acid. The ic acid gets replaced with ATE. For this one down here, it's made from butanoic acid and isopropyl alcohol, so it's isopropyl butanoate, the ic acid being replaced with ate. Note also the space between the ethyl and the heptanoate and the isopropyl and the butanoate. This one here is a little bit different, because now we have an alcohol group, but the OH is on the end of the chain. The complication here is that we need to state where that OH group is on the chain. Here it didn't matter because isopropyl alcohol is this specific alcohol, but in this case the OH needs to be stated as being at the end, so that's why we make it 1-propyl or perhaps N-propyl alcohol, and this would be 2-chloropropanoic acid, so the name would become 1-propyl 2-chloropropanoate, again the ic acid being replaced with the ATE, and the 1-propyl coming in here showing that the alcohol group is on the end of the chain. So this positioning portion here is going to also be important. Propyl alcohol just won't be enough. Amides, again, are named after the carboxylic acid from which they're made. This would be 3-bromo 2-nitropentanoic acid would be the carboxylic acid if this was replaced with an OH. And the oic acid part is replaced with amide. So this becomes 3-bromo 2-nitropentanamide. So they always end in amide. Now in this instance, there is no substituent on the N, so it's just 3-bromo 2-nitropentanamide, indicating the bromo groups and the nitro groups are on a chain. Now if it so happens that there are groups on the nitrogen, we need a way to identify them as being on the nitrogen. And the way we do that is to use the N prefix. In this one, it's N, N dimethylbutanamide, indicating we have a methyl group and a methyl group of the nitrogen. It's not enough just to have N dimethylbutanamide, because we need to specify that both methyl groups are coming off the nitrogen. The N here is a capital N and is always written as a capital N because it's the symbol for nitrogen. This one here has a methyl group and an ethyl group hanging off the N, so it would be called N-ethyl N-methyl propanamide. Again, this would be from propanoic acid. Nitriles always end in the suffix -o-nitrile, but the number of carbons in the chain also include the carbon that's part of the nitrile. And there is a C here, even though it's not drawn in specifically, because it's a line structure. But if I was to count the carbons, it'd be 1, 2, 3, 4, 5, 6, 7. So it's heptanonitrile. If this was a carboxylic acid, it would have been heptanoic acid. This is benzonitrile, which would have come from benzoic acid if that was a C and a carboxylic acid over here.